Yeah, let's go.
Okay, so Iron Man suit. Do you know much about superconductors?
I've studied a little bit about it in my physics classes, so I just know a little bit. I'd like to learn a little bit more about it.
So basically, a superconductor is like a magnet that's spinning. So imagine this magnet. It's like here's a magnetic field, and then it starts spinning in this direction. Can you see this?
Yeah.
Okay, so basically, if this is at absolute zero, so 0 Kelvin, it looks like okay, but it says 0 Kelvin, then that means that this will spin infinitely. Isn't that pretty cool?
How is the spin produced?
Well, we'd have to generate the spin, but it could be through any way. Like you could just like do that. Like you could touch it with the glove and it would spin forever, infinitely.
So I understand that. Where does the source of the generation come from?
So good question. So for the Iron Man suit, I had the proposition, you know, the arc reactor, how
Yeah,
like
I'm familiar with the
Stark
physics.
has an arc reactor. So my idea for the Iron Man suit, instead of an arc reactor, we have superconductors because they generate, this is infinite work.
Yeah, that makes a lot of sense, actually.
So there's infinite spin, which means infinite work is being generated.
Does infinite spin provide infinite perpetual motion?
Yes.
All right, let's
So
go.
now here's my idea. I was thinking for the arc reactor, we use superconductors, right? So what if instead we have a bunch of plates, except you know how like a sphere works? Or you know how you take the integral of a sphere, it's like you take slices.
Yeah, I've taken all of those courses, so I'm pretty familiar with spheres and integrals and all that sort of.
Okay, so here's a sphere. You take slices. So now imagine this is an onion but these are metal sheets that are at absolute zero. So now it's at absolute zero. And now imagine each thin plate is spinning in some direction, and then they cancel each other out with the spin. So you have enough of these spins with like a core center ball, and the ball spins a certain direction as well, okay? So this spins in a certain direction. And how about this ball controls the spin of all the other magnets?
Yeah, that
So
makes sense.
rotate.
How can the how does the ball control a spin exactly?
So we have to control the spin of this ball somehow. So my proposition is that we use some kind of magnet or electrical current. So if we combine this with electricity, now we can change it a lot.
Okay.
What do you mean?
So I'm talking about electromagnetism right now. So like electricity affects magnets and magnets affect electricity. So if we have this sphere of like infinite layers of these metal sheets that are all at absolute zero, and then we start generating, we combine electricity with the sphere and we generate like spin and everything starts spinning and whirring, then we have infinite work all of a sudden. Hold on, someone just joined, let me admit him. Does that make sense? Like we have infinite work. Hey, Taylor. We're just talking about the real life Iron Man suit right now. So to
Yeah,
get you caught up,
pretty interesting. Welcome.
yeah, so basically, Tier, to get you caught up, we're talking about superconductors and magnets. So like this is all at 0 Kelvin, and I'm talking about like a superconductor with a sphere at the center, and then we combine it with electromagnetism with physics, and then we have these sheets. It's like an onion, like this is a sphere, and these are layers. We have layers of these sheets of metal that are infinite, that generate infinite spin. So infinite spin means infinite work, because that means there's infinite motion. So this is what we're talking about right now.
For these spins, I see you have some arrows on the whiteboard, and then like one was going the other and one was going a different direction. Are they supposed to be like counter current to each other?
Yeah, these are all supposed to cancel each other out at the end. So they need to all be in 3D directions in which it's in every direction.
Oh, okay, that makes sense.
How are they like suspended? How are they like suspended around the superconductor?
So good question. A superconductor, the way it works is like the magnet floats above it. So there would be some kind of magnetic field. This would be a magnetic field, and this would be floating. And now these are all magnets at absolute zero, right? So if these are all magnets at absolute zero, then that means they're all going to be suspended and they'll all generate infinite spin and infinite work. Does that all make sense?
So my understanding of absolute zero is that at absolute zero, there is no molecular movement. And
Yeah.
superconductors you achieve by getting really close to absolute zero. But
Yeah.
if you like were to have, if the sheets are spinning, then isn't that by definition not absolute zero? I do apologize.
Right.
It's been a long
So
time since I've been in school.
I think that should be accounted for. So it should stay absolute zero at the core. And as it gets further out, it generates more torque from the spin and it gets lesser than absolute zero. So we need an absolute zero core. This needs to be absolute zero. And the outside's going to be approximately absolute zero then.
But so that means that the outer shells are increasing from the sphere, from the rotating sphere, like in temperature.
Yeah, so the temperature is increasing.
But like at a negligible rate.
Yeah, the negligible rate because there's all these layers. So I think this is the equivalent of the arc reactor. This is a real life arc reactor. Because if we have infinite spin, then we have infinite work, which is what we need.
But how are you going to harvest like the work, right? So it's like, yeah, they're moving infinitely, but
good question.
How I see it.
Another question, if you could piggyback off this other one to answer in a second, how does I understand how you can get infinite work from infinite spin, but what powers the infinite spin would be my question.
So the infinite spin would be powered by being at absolute zero. If it's at absolute zero, then you could just like do this.
How does the absence of energy produce energy? Because absolute zero means that every molecule in the matter is completely still. So how
we
do
would
you
need
all energy?
We would need some kind of thing we need something to like get rid of heat. There needs to be something in this chamber to get rid of heat. Something in this chamber is going to ventilate heat out at a crazy efficient rate. So
but how does that produce infinite spin?
Okay, so now there's infinite spin because this is a vacuum of 0 Kelvin. Okay, now it gets like
what provides the force in the vacuum for the spin to occur?
Okay, it could be electricity because electromagnetism. So now we add an electric current. We add an electric current and this ball starts spinning. And it creates a bunch of magnetic waves and these all start spinning. And then you harvest the work at this approximately 0 Kelvin, but it's higher than 0 Kelvin.
How can an electric current exist in a vacuum though if the electromagnetic force is mediated by particles?
Well, that's what we're figuring out right now, isn't it? So that's a good question. I'm trying to figure that out with you chemistry and physics majors.
I see how in a true vacuum it could work. My only place where I'm hung up is the electromagnetic force is mediated by particles, so it couldn't exist in a vacuum, a true vacuum.
Okay, so how about we create the Iron Man suit within a black hole? Or we make it in space. If we need to make it in space, then let's do it. Why not?
Well, particles exist in space also, so it's not a true vacuum because the electromagnetic force has mediators in space.
Well, what's a true vacuum?
There's also resistance to an infinite spin through particles.
What's a true vacuum then? A black hole?
So I'm sorry, can you repeat that?
I said, what's a true vacuum? A black hole or what?
The absence of all matter.
The absence of all matter. Well, that sounds like a black hole to me.
But a black hole has mass, so therefore it has matter.
In my understanding, a black hole is hyper condensed matter.
Right. A vacuum
Like
or a black
space
hole
is
can
like
be
a near
vacuum.
perfect vacuum, but it's not quite a perfect vacuum. Perfect vacuum is entirely devoid, whereas space is only mostly devoid.
Okay. It is impossible to make a perfect vacuum. The problem is that to maintain a vacuum in a region, you have to shield it from the environment. It's not difficult to make a container that will. Okay, so look, we can make a perfect vacuum. We can make the perfect vacuum.
But then if there was a vacuum that prevented particles from entering, then the electromagnetic force couldn't be mediated.
Hold on, let me read this. The first problem is that the container will radiate photons if it is not kept at 0 Kelvin. Note that perfect vacuum has, by definition, a temperature of 0 Kelvin. Reaching 0 Kelvin is practically impossible. The second problem is that there are weakly interacting particles that can enter the region. No matter how thick the walls of the container are, there's always a finite possibility that, say, a neutrino would enter. Okay, so my solution to that, so this arc reactor needs to have enough layers. It's going to have n times layers. N. So when n reaches to where it's insulated enough, I'm going to say n equals insulated layers. When n equals insulated, then you're good. Then we've got it. And we've got the vacuum. We need to make a perfect vacuum to make this work. So this ball region needs to be a perfect vacuum. This needs to be a perfect vacuum. And it needs to be 0 Kelvin. So 0 Kelvin chamber.
So basically the scientific progress that would need to be made on this is to create a perfect vacuum where the electromagnetic force can exist. So that's the research that would need to happen.
Exactly. That is my opinion. So we need to be able to create a perfect vacuum. And then we'd have infinite work in a perfect Iron Man suit.
Okay, I see what you're saying now. I'm satisfied with that.
Perfect. So this is the next steps.
So my question is, so like, again, they're going to be spinning infinitely, but, and like, if we're trying to like use like the electromagnetism from them, like we're trying to harvest that, wouldn't harvesting it eventually slow it down again?
Well, yes, it would start getting slower, but how about we harness the power of the spin as it gets to 0 Kelvin? As it gets to N insulated, we start harvesting the layers. And then we let the drag of the air in between the layers catch on, and that'll be the friction. So the air pockets equal friction. These are all friction pockets. And we're going to harvest the spin, or we're going to harvest the infinite spin from that. And that's how we would get all the work. That's what it takes to make a real life Iron Man suit.
But then, so right now, the big if would still just be to create a vacuum that can have the electromagnetic force still mediated inside it.
Correct.
That's what it's
This
missing.
is still the question.
Yeah. I'm still just not sure on the mechanism, right? So it's like harvesting the friction, but
imagine you have like a ball and it's spinning, right? And then imagine there are all these like oscillating like plates that are spinning, and they're like canceling each other out with the spin. And instead, all the energy from the spinning, like all these layers, like they're barely floating. Like the layers are like infinitesimally close to each other, but they're all spinning. There's air pocket layers in which a neutrino can penetrate. But then there's an insulated chamber of 0 Kelvin right here. That's here. This is insulated from the world. This is a perfect vacuum.
Yeah.
So we have this perfect vacuum ball, and then we have all these layers that are like near absolute zero rotating around it, and it keeps canceling each other out. And we harvest all the energy from the spin from the perfect vacuum. So like imagine all this spinning going on. It's like all this crazy, like near infinite spinning, and it's all getting harvested for energy because we have a perfect vacuum now.
Yeah.
And so then with that energy, you can do all the function of the Iron Man suit, basically.
Exactly. Exactly. You want to freeze someone, you just take it from your chamber, your insulated vacuum. If we have a perfect vacuum, then we have an Iron Man suit. That's the solution. Because then we have infinite energy condensed.
All right. So at that point, then with the one problem of creating the perfect vacuum, which obviously is the one thing that needs to be solved, I'd say I'm satisfied with the information. I thank you for sharing this with me.
Yeah,
that's all I wanted to see. I always love having scientific discussions. Obviously, like chemical engineer, like I like talking about it. Thank you very much.
Yeah, of course.
Best of luck in your future scientific endeavors, man.
Oh, I would just add that an alternative would be to harness the power of a star inside the suit, but that would require a lot of insulation. So what are the next steps? We need a perfect vacuum, but we also need perfect insulation. So if you could get on that, like chemical engineering, we need a perfect vacuum and we need perfect insulation. Because without perfect insulation, we don't have a perfect vacuum. And if we have perfect insulation, then we can have a mini star. Imagine you have the core of the sun inside a suit.
The scientific concepts of insulation and creating a vacuum are similar. So it could be possible that once you find the material that works, it could work for both. That's
it may very well be a black hole. I'm just going to be honest, it may very well be a black hole. Like if we need a black hole and we need like a singularity object, then I say let's do it. Like if we have to
my only issue with that would be, my understanding was that a black hole was extremely dense matter, which would not exactly be a vacuum, although I would admit that there could be some way to utilize a black hole for the creation of a vacuum.
Yeah, what if we were to like make so black holes really dense matter? What if we were to make a shell out of matter as dense of a black hole? Because like that would work as an insulator, right?
Or use a black hole to suck the matter out of something.
Okay, so
well, that's what I'm saying. If we were to make a shell like black hole,
no. So like
nothing would be able to get through it.
Here's right. So look, check this out. If we surround the black hole with, let's say, neutron stars, then it'll cancel the gravitational field, and this will be neutralized. We can neutralize a black hole with neutrino stars, and then this goes away, and then we can extract the black hole. But it'd have to be a very careful operation. And it would require us to move around some stars, but we could do it.
I see what you're saying with that.
Like we can disable the gravitational field by carefully placing neutrino stars around it.
Do you know could possibly move those stars?
I don't know how we would move the stars. That would require a lot of science and engineering, like breakthroughs.
Yeah.
All right. Well, once again, like, man. Oh, go ahead, Tier.
I was gonna say, it has been a long time since I've had to do any kind of science, so I really just don't know this kind of thing. I'm like,
no, I have no idea how I would move a star either. I mean, if we want, we can Google it.
I was gonna say I'm satisfied with the information you've given here. My real concern was about the infinite work, but I see what you're saying on that now. So thank you for sharing, and have a good rest of the discussion. I gotta go somewhere now, but thank you.
Okay, yeah, I'm glad you enjoyed it, and try to find. I mean, ask your research faculty and give them the ideas, because I want to see this happen, dude.
Yes, sir. I agree. Although I would add that the creation of that vacuum probably has a lot of work in front of it, but
yeah,
I respect the idea. I respect the idea. It's definitely given me a lot to think about. So thank you again.
Yeah, no problem, bro. All right, well, good luck with the information, dude, and good luck with school. All right, he's left, so you can talk freely now. I'm just looking at a neutron star, what it is. It's 10 to 25 solar masses. That's pretty big. Possibly more, except for black holes and some hypothetical objects. Strange star.
I was gonna say I've never heard of a strange star before, or a quark star.
Yeah.
Well, honestly, I mean I've heard of light holes, but like always in techno babble. where it's like,
Dude, holy shit, look at this. This is made entirely of quarks.
huh?
Nuclear particles to form quark matter. Dude, maybe this is going to be a solution.
Yeah, no, that would be I don't know. I don't know enough about.
Dude, we may very well need to have a quark star to make an Iron Man suit. I'm not even kidding. Like an Iron Man suit is so advanced, people don't even realize.
Yeah. Well, yeah,
It's infinite
there's
energy.
a lot of energy, or rather, it appears to be like energy, super energy.
Yeah, like it doesn't show Tony Stark charging his core when he goes to bed because he needs it for his metal heart stuff.
Yeah.
Strange quarks are, relatively speaking, a very rare type of heavy quark particle. Holy shit. Dude, this is a solution. Holy shit, look. Near zero external pressure and temperature.
Yeah. No, they wouldn't radiate much of anything, it looks like.
The Bodmer-Witten assumption. Quark stars are made entirely of quark matter, which would be stable if they quickly transform into strange quark matter. Dude, I think we need to make a quark star. I'm not even kidding.
I just don't know how to do that.
Well, I'm trying to figure it out. Quark, made of strange quarks in nature, the core of neutron stars. Speculatively, as isolated droplets that may form varying femtometers to kilometers, as in the hypothetical strange stars. At high enough density, strange matter is expected to be color superconducting. Holy shit, what
does that mean?
Let's see. Phenomenon predicted to occur in quark matter if the baryon density is sufficiently high. Holy fuck, this is advanced.
Yeah.
A baryon is a type of composite subatomic particle which contains an odd number of valence quarks. Holy shit, we're talking about valence quarks now? Good God. This is a fermion because they have half integer spin. Jesus. The temperature has to be well below 10 to the 12 kelvins. Color superconducting phases are to be contrasted with the normal phase of quark matter, which is just weakly interacting Fermi liquid. Hypothetical theoretical model of interacting fermions that describes the normal state of metals at sufficiently low temperatures. Oh, this is what we want. We want the Fermi liquid theory for the Iron Man suit. Do not need to be small. Okay, the phenomenological theory by contributed to theoretical physics in 1956, developed by Alexei Abrikosov. Condensed matter physics and Isaac Kalatnikov. Theoretical physics, quantum. Holy fuck. The Feynman diagram is a pictorial of the interaction of subatomic particles. Dude, we're going deep in this fucking rabbit hole. Perturbation theory. Approximate solution to a problem by starting from the exact solution of a related simpler problem. That's simple enough. I don't need to read too in depth in that.
Yeah, no, that makes sense. It's like extrapolation, more or less.
Yeah, basically. The theory explains why some of the properties of an interacting fermion system are very similar to the ideal Fermi gas. I think this is also related to the Iron Man suit. Electrons, protons, neutrons in general, particles with half-life, half integer spin. These statistics determine the energy distribution of fermions in a Fermi gas in thermal equilibrium. So we need thermal equilibrium, but like 0 Kelvin, and then like something that's not 0 Kelvin.
Yeah. So for thermal equilibrium, it means that we want the temperature. If we were to get the temperatures approximately the same, there would be approximately in thermal equilibrium. We just need to make it that That's why we have so many layers, right? Because it's like you just want to make sure that the temperatures aren't too different, so there's not too much flow, because it's like a perfect anything is really hard to get. You can just approximate it, right?
Yeah, so we basically need this.
Yeah, we need a
High, one
0
low.
K to equal, yeah.
And I don't know what the margin of error would be. My guess is it's going to be 10 to the -8. It's just my guess for what we're shooting for.
Yeah, no, and I'd say again, like the small better, right?
Yeah, 10 to the -8 Kelvin is my guess. That's just my guess though. Like if this difference is only like 10 to the -8, then I don't see it failing. And I just chose that number because it's the speed of light.
Yeah, that would be a nice coincidence for sure.
Yeah, well, so like you need the speed of light for this Kelvin thing. So I'm just going to assume it's less than 3 to the -8. 3 times 10 to the -8. Because I'm just going to choose the speed of light arbitrarily. Models
That seems fair to me.
Enrico Fermi. Yeah, I mean, it wouldn't surprise me if it was required that was like the speed of light. Neutrons and neutron star and electrons in the white dwarf. Holy shit, that's really cool. Yeah, we're getting places. Non-interacting fermions and why other according examples of where Fermi liquid has been successfully applied. I'm just going to keep the gas one open. Liquid helium. Liquid helium is a Fermi liquid. Holy shit, that's cool. Is a Fermi liquid? Maybe we need liquid helium for the suit. At low temperatures, it's a Fermi liquid. And a Fermi liquid.
I would think that you would want a gas, because so it's like a gas is further away from a solid, and since we have layers of solid.
What if we had liquid hydrogen? Because that's even lighter than helium.
Is it?
Yeah, it's number 1. Watch. Hydrogen's number 1.
Oh, yeah, there you go. Yeah, so
What if we have liquid hydrogen now? I think that fixed it.
But isn't like liquid helium more stable, because it's like for the first layer of valence electrons you want 2 electrons, and so helium.
Oh yeah, that's true.
Gas.
The atom itself is a fermion. The electrons in the normal non-superconducting. Oh, superconducting, look. Dude, it's all tying together now. We're really cooking with fire. Vanishes and magnetic flux fields are expelled. I wonder if that's helium that they're pouring. Holy shit, this is what we need, bro.
It's floating, yeah. No, I see that. Looks like what we'd want.
It is exactly what we want. It's only explained by quantum mechanics. This is exactly what we're talking about. The Meissner effect, let's see. Expulsion of a magnetic field from a superconductor during its transition to the superconducting state when it is cooled below the critical temperature. So we need the Meissner effect to happen. Maybe by liquid helium. We're gonna have a sphere. It has to be a sphere. So I just wrote that down. Liquid helium to the Meissner effect.
Yeah, I see.
I'm gonna say it has to be a sphere that weighs 1 kilogram exactly. Because they have a sphere that weighs 1 kilogram exactly in the world. We're gonna make it magnetic. Look. They already have a perfect sphere out there in the world. We're gonna make it out of metal though. We're gonna make it out of the same metal as this. NdFeB.
Do you know what kind of metal that is?
I have no idea. I'm just gonna write it down.
Yeah, because I'm like, so it's got iron in there and boron. I don't know what Nd is I don't know what element that is.
Me neither. Let's Google it. It's a neodymium magnet. That makes sense.
Yeah, no, I don't need
We're gonna have a neodymium sphere.
Yeah, I wonder how hard that'd be to make though.
Yeah, to make it a perfect sphere, it probably wouldn't be easy, but I think it's doable. We may have everything we need to make an Iron Man suit already. Just based on looking at all this.
I still think it'd be really hard to make the like to keep
vacuum
the core isolated enough. I still think
that's the thing. It's like we can just reverse engineer all this shit. Like all we need, if we can get a perfect vacuum with perfect insulation, and we're set. And we already have the idea to make like a layered ball with like all these in a vacuum, like a ball in a vacuum with all these rotating plates. All we would need, we could even 3D print this shit. If we have a bunch of neodymium like magnets.
Well, I was gonna say, I don't know if you can 3D print a neodymium because as you heat things up, they lose their magnetic charge. And so traditionally, or as far as I know, how 3D printers work is they like melt something and then it cools in the shape. And I don't know if you could do that with magnets, but yeah, so like heat with magnetism.
It's possible.
Yeah, here you are.
Good job, MIT.
Yeah, good job, bitches.
Bro, we could take this Iron Man concept to MIT right now and be rich. How does that feel?
I don't know if to go for it, to be honest.
You don't know? Watch. I'm gonna contact them right now. All right, Professor Jamie Pereira.
Oh yeah, email, professional.
Yep, we're keeping it professional. Don't mind my cluttered. I received a privacy complaint. Are you kidding me? Hold on, let me see what this is. I still have, look at all these dislikes. This bullshit. Dude, you can't preach about unconditional love and dissolving the ego and then objectify women like they're entirely different species and then talk about treating your family like shit. They're fundamentally at all. If your response is that you just do whatever you feel like and don't give a fuck and you do not believe in unconditional love, if that's the case, it is only a sad, sad life to build oneself up at the expense of others. Everyone deserves love and happiness. And check this out. Look at this rebuttal. Unconditional love, ego, objectify women like different species, treat family like shit. That equals do what I want, don't give a fuck, which means I don't believe in love, which means I build myself up at the expense of others, which means I find joy in taking from others, which means everyone should live a happy life. Well, here's the incorrect logic. Wilson causes suffering. Wilson is a bad person. No one should suffer. Except the problem with that is, hold on. I just want to show you this. There's literally a scientific article when pain and effort increase pro-social causes.
I don't know what a pro-social contribution is, to be honest with you, Chief.
It just means like it's for the people. Positive, helpful intent to promote acceptance and friendship. So this literally, suffering makes you more friendly. That's what this is saying.
I mean, I would agree. I think suffering increases empathy.
Yeah, it does. Like, look at this shit. Anticipated pain and effort lead people to ascribe greater meaning to their contributions and to the experience of contributing. It completely, they like miss this point. And also this person agrees. Anyhow, I'm just going to email this professor. Working iron suit were curious as to your expert opinion on the subject matter, given you are a highly esteemed professor at a highly prestigious STEM university. Your design revolves, pun intended, around creating an infinite vacuum object which would contain a neodymium or spherical magnet of approximately 1 kilogram. No, of exactly 1 kilogram in mass. This object would then be subjected to a perfect vacuum, which means existing at 0 Kelvin. This spherical core would then be surrounded like an onion with layers by infinitesimal thin sheets of spherical cutouts of neodymium. The sheets would then rotate and eventually cancel each other's spin out, and the core sphere would dictate the direction of the surrounding infinite metal neodymium sheets. From this core or arc reactor, if you will, work would be generated due to the infinite spin nature of superconductors. Let me know your thoughts on such a design. I believe that liquid helium, a fermion liquid, would be a core component in order to create the necessary vacuum surrounding the neodymium sphere core. Thanks. What do you think of the email? Is it good?
I would move the like let me know your thoughts on the design. I would have that be the last thing before the sign off. Because the liquid, like the Fermi liquid, like that needs to go up above it so that way he can read all of it before he reaches that part, you know. But besides that, I think it will read clean.
Okay, cool. All right, sent.
Awesome. Let me know how that actually ends up turning out. I also,
yeah, I'm really curious what he ends up replying.
Yeah, no, like I was saying, I think that probably a good chance, and I want to know his thoughts on it. But I got a text from my dad that I need to go socialize with like my living parent or relatives now.
Yeah, you're all good, dude. I think we got all the important stuff on this recorded. So I'm gonna post this. I'm gonna post this on my Instagram bio so you can rewatch it at your leisure.
All right, I appreciate it, man. Take care.
All right, take care, buddy. See ya. Well, no one is left, so I'm just gonna end this recording and this lecture because no one's here. Well, we got the Iron Man suit though, so that's cool.